Oh yeah, so hello guys, welcome to, so today I'm going to introduce the BAYSED. So it's an AI agent memory hub. Let's start from the beginning, the problem. So nowadays we're living in the world where AI agents are evolving really fast. Everything happens like a snap. Every night, new model comes out. But it's really fast, but there's one bottleneck actually holding everything back. That is the memory. So basically, AI agents don't have a persistent memory. So which means it will just forget everything after they are done with the interaction with the user, or the user just ends the session. So because of that, well, the memory itself becomes a platform dependent, which means it will be disposable. So for better understanding, let's go with this example here. So user A created an agent. This agent is capable of making a contract, deploying it, and interacting with it, which is really awesome. So these guys come by and say, oh, I really want to use your agent. But actually they can't, because as I told you before, the memories are kind of dependent, and it's in the platform so they can share it. If they want to use that agent, they have to reprompt from the sketch, which takes a lot of time, and it's unnecessary. So basically, that's where the BAYSED idea comes from. So what is BAYSED? So BAYSED is a memory hub for AI agents. So users can share their memory or trade it with their programmable unique ID, and we'll just save it there so they can use it later. So why does it matter? Guys, imagine it. So there is a chat log between Vitalik and his ChatGPT. You guys want to buy there, right? Or maybe there is a AI waifu that people want to buy it. They can just post the memory there so people can actually buy it. The AI agent's personality becomes more portable, composable, and monetizable. So this is how we made it. I call this the Triforce of agent. So there are two, actually it's three, but two main cores that's supporting the BAYSED. So we use Walrus as a data layer, so we can store the memory there, and we use the Tusky so we can actually encrypt that memory so that people who have access can download that. And we use the story protocol to actually handle all that IP, registration, inheritance, and distribution. So actually, the using story protocols makes it really, really interesting, because like, for example, I made a model. I made the memory, and I deployed it on the BAYSED, and someone just bought the IP, they download it, and they improve it. They maintenance it, and they redeploy it again. So that time, we created something called derivative IP. So when some other people use that redeployed AI, the memory, the original creator and the contributor, they both get the reward. Of course, the contributor will decide how much they will be paid by contribution and talking to the AI, or negotiating with the AI agent. So this is the whole flow, which is kind of easy. We're starting from the top, going clockwise. So the user deploys agent memory, and memory is uploaded on Tusky, and after that, NFT is issued on story protocol. That NFT represents the ownership of that memory. And after that, people buy that IP and enhance the memory, and they just redeploy it. And that's the time when I told you before, the derivative IP is created. So the circle goes on. This is the basic incentive model to encourage people to maintain that memory. Let me show you the quick demo here. So we got the agents here. So this agent is capable of deploying contracts. So we want to export this. We use story MCP. We put it here, and after that, it will going to deploy this memory. And this is the IP created, and there is a trait which is uploaded to Tusky. So this is basically the key. So if other user buys this IP and just import it, now there's zero memories, but when they import it, there is 4 memories. So we believe that memory is ownership. BAYSED turns AI memory into assets, shareable, ownable, programmable. Thank you.
Judges. Do you have any questions? You haven't asked. Would you like to go? Okay.
Just how do you see this, like assuming BAYSED becomes super successful, how do you see this kind of fitting into, larger crypto space and economy?
The crypto space and economy. Well, for us right now, I think the derivative IP system itself kind of fits to the Web3 system, the blockchain ecosystem, because it encourages people to contribute to the AI agent's memory. So I kind of think that incentive model kind of makes, that's a whole token economy, so that people can actually spend their money and burn the token, stuff like that. Yes.
From the very conventional legacy business standpoint, what sort of some real business use case can be created using your solution, like remixing the memory?
So, like the market fit, yes, I like that. So I think that for me, it's kind of like a domain specific. So it can fit into a lot of domain. For example, some doctor, I mean, not all the doctors use ChatGPT, but they're probably gonna have an AI agent specific for the medical stuff. So they trained it, but medical information is really important. It's their actually time and money. But they can't just let other people use their memory. So they can actually use that IP and sell it to people. And people who try to contribute it, they will get the IP as well. So I think that could fit in that. Basically, that question is more like how could AI agent could fit in the market? Yes, which goes like that. Yeah.
So you have a marketplace here. How would you bootstrap it?
Oh, sorry, what was that?
So you have a marketplace, right? You have kind of agent memories, right? And then people who want to use them. So you have kind of two sides. Yeah. So how would you bootstrap this marketplace, like to have enough supply, have enough demand?
Yes, that's to be honest, I never thought of that. But if that happens, I think that is more like so we're thinking of putting the marketplace and the AI agent. It's really hard to actually compare. 뭐 있을까? AI agent와 marketplace를 어떻게 하면 바꿀 수 있을까? Okay, so basically, I'm really sorry. I'm thinking. So, yes, marketplace. Sorry. Yes.
It's okay.
Yeah, it's on our roadmap.
Next step.
Next step. I guess it's in our roadmap. I just wrote it down. Yes.
I just had one
yes.
technical implementation question.
Yes.
Is the memory implemented as like a LoRa adjustment to the base model, in the actual weights, or is it like a kind of memento series of memories that it will refer to, or a combination of those two?
It's really So yeah, we basically have that memory as a reg, which is a context-based data. So yeah, we're not using both. It's more like a JSON and reg. So it's more like a context. They store like what logical, the reason why this AI agent thing in that way, or the input, and the reason why they put that output, and some kind of like a small information about the input user. Yes.
Okay. All right, thank you.
Thank you.